Alright, let's go look at homework part 2 of 4 in homework series 3 in advance of our test on the 26th of October. And so for the function below, define the domain and range by locating vertical and horizontal slant asymptotes if present. So hopefully by now you've got a chance to watch the videos from the other students, and so you have a good sense of like what types of asymptotes and what the shortcuts are going to be. If not, you can always revert back to division. That's always going to be a good thing. So if we're trying to find horizontal slant asymptotes to define a domain and range, let's please make sure that we have an understanding that the vertical asymptotes are going to affect the domain, and the horizontal asymptotes are probably going to affect the range. There is one more piece of this puzzle. We're going to discuss it on Tuesday of next week, and just kind of going through that work next week. But please understand, like, this is only the first part of this, so it's a preliminary part. So there might be a piece missing, particularly with the range, but that's not something I'm willing to go into right now. And these problems are picked, so you can probably assume the horizontal asymptote will directly affect your range. Anyway, let's get to it. So we need to find the vertical asymptotes. So recall vertical asymptotes are going to be defined using the denominator of this rational function. We're going to ask ourselves what value of x makes that 0, because that will define our vertical asymptote. And so we don't have to be heroes about this. We can just set up the equation to solve. So 2x plus 3 is 0, so we can find the value of x. So if we subtract 3 on both sides and divide by 2, we'll find that this x value is negative 3 over 2. Now this will ultimately affect our overall domain, because if we do have a vertical asymptote here, that means we can't cross that line, we can't take that value. So the function, when it comes in, will start to curve downward because we can't hit that value, which will definitely affect our overall domain. And so the way we'll write this is to think about where we come from as far as our end behavior. So as we go to the left-hand side, that's going to be going towards negative infinity, and we'll find that our value is going to tend to a number, and then we're going to jump, and then we're going to continue going to infinity again. And so when we write our domain, we have to reflect this jump. And so our x values start at negative infinity, and then go all the way to negative 3/2. And then they're going to start again at negative 3/2, and then go all the way to infinity. Now we have to unionize these sets together using that u in the middle to show that these actually talk about the same function and not two separate functions. So that's our domain. Now let's talk horizontal asymptote. Now if we were to go ahead and do the long division, we'll find that 2x goes into 4x twice, which leaves that little remainder, but we know at this point that remainder will tend to 0 as numbers get very big. And so what we're left with is just a 2, which means our horizontal asymptote is going to be just y equals 2. So the interesting part to talk about now is whether or not this affects our overall range. At this point, we can just assume it does, and so we can set up a similar thing as our domain. So our range, our y values, looks like it's going to cover everything but y equals 2, and so we can set it up the same way. So we have negative infinity that goes all the way to 2, and then 2 to infinity, and we can unionize the set because they belong to the same function. So let's do a similar thing here. For the function below, find the domain and range by locating the vertical and horizontal slant asymptotes, if present. So let's go ahead and go with the vertical asymptote first, because that's straightforward, especially because it's given to us in basically factored form. So x equals negative 2 will be our only domain violation. And so, again, if we think about the graph, at negative 2, we're going to have this thing. And then we're going to have a function come up to that and leave it. So we have negative infinity to, negative infinity to negative 2, negative 2 to infinity, unionize the set, there's our domain. Now for our range, it looks like we're going to have to do some division here. So x plus 2, x squared plus 3x minus 5. So x goes into x times, so that's x squared plus 2x. Subtract, we end up in x minus 5. So it looks like we're going to be a plus 1, x plus 2, with a remainder of negative 7. But of course, that doesn't really matter at this point. So we're going to have this x plus 1 slant asymptote. So we're going to actually have an asymptote that comes in like this. And so we have a good sense of what this is going to do to our function. We can note that although we might have some things happening in our range in the middle, we're definitely going to go from negative infinity to infinity, or from negative infinity go to infinity, but the middle might be a little bit hard to ascertain. And so at this point, because it's still a mystery, I'm just going to put a question mark here for range, because I think we need to do a little more work before we can kind of get that piece into our analysis. All right, so let's go to some prep for the future. We have this function 2x squared plus 2x minus 4, and I'm asking you, well, what's going to happen when you put in negative 2 and 2 for x? Will you end up with the same values, or will you end up with different values? And so, although I'm not going to go in detail of that, just like last time, I'm going to point out what kind of x's you have here. So now you have two different values of x. One is squared and one is not. And so make your prediction of whether or not you'll be the same values or different. And let's go ahead and do the actual algebraic work. So if I'm looking at f of 2, that should be 2 times 2 squared plus 2 times 2 minus 4. So 2 squared is 4 times 2 is 8. That's going to be 4 here minus 4. So the overall value is 8. And so you made a prediction whether or not negative 2 is going to produce the same value. Let's check it out. So here we have negative 2 squared, which is 4, times 2, which is 8. So that looks like we end up with the same value. But here we end up with negative 4 because that one's negative, and another minus 4. So this one actually ended up being straight 0. So in this case, they're not going to be the same value. Now, if you're reflecting on why that was, again, I'm going to point back to the x's and point out that one is squared, and the other one is just an x. Okay. So we have end behavior, max and min points. So remember, end behavior is going to be talking about what the y values are as they get bigger and smaller. Max and minimum points are going to be that laser focus in the middle. It looks like we do have a little bit of both action things happening here. So let's talk about end behavior first. So let's talk about in terms of limits. So the limits as x goes to infinity, and the limit as x goes to negative infinity. We are talking about this function f of x that we don't really have much knowledge of, but we have the graph. And so as x goes to the right, as x gets very, very large, it looks like my value is increasing and should increase that bound to infinity. As I'm going left to negative infinity, looks like my function's diving, so it's going to be a negative infinity graph. So two more things, we need a maximum minimum. So it looks like we have 2 points here. And so roughing it out, looks like we're at 1, 1, 9 here for our max. It looks like our minimum is going to be at 3, 5. And our min is at 3, 5. All right. Sketch and find the domain and range of the function. Again, the first thing you should probably do is check out the parent function p of x, which is going to be the absolute value of x. The graph of the absolute value of x looks roughly like this, with an important point here at 0, 0. So if we think about this original domain and range, the domain is going to go from negative infinity to infinity. We can take the absolute value of anything, and the range is going to be from 0 to infinity. Square bracket, of course, because we can actually use that value. And so now we can examine what the function is doing, how that's changing. So we have this f of x value, negative 2, x minus 4, square it up, minus 3. So this is going to shift it down 3 units. That's going to shift it right 4 units, excuse me. And then two things are actually here. This is going to be a times 2 multiplier, so it's going to be skinnier, but it's also going to flip. So that's going to affect our y value. It's going to flip it down. And so if we track, say, this 0 point, we're going to move to the right 4. 1, 2, 3, 4. We're going to move down 3. 1, 2, 3. It's going to be skinnier, and then we're going to flip over the axis. So, okay, so right before the flip happens, it's important to note that we have this going on. And so that takes care of the shift down 3, moving to the right 4, and the skinnier. Now this is going to flip over the x-axis, which means we're going to flip over this axis. And so this point that was at 4, negative 3 will flip straight up, and it's actually going to be at 4, 3. It's still going to maintain its skinniness. It's just that now it's going to be opening the other way. So in its final form, we'll look at this axis right here. So it moves to the right, it moves to the right, then down, skinnier, and then flip over the x-axis, and that's what that negative does. And so we end up with this this last piece. Now for the domain and range, the domain, although we did technically shift it to the right 4, since we're dealing with infinity to infinity, a change of infinity really means nothing. Now for the range, though, looks like we're going to start at negative infinity, which is the lowest most point, and then we're going to go all the way up and touch 3. Square bracket, of course, because that point is our maximum point. We can, CAN, reach it. So it looks like we now have to find the zeros by any method. The first thing I'm looking at is a cubic with all the pieces, so I'm going to hope by factoring by grouping is going to be my best bet. So remember, by factoring by grouping, we're going to break this off into 2 distinctive parts, and we're going to factor each part separately. So the first part, I have x cubed plus 5x squared. So I'm going to rip x squared out of both terms, leave me with an x plus 5. Now that's really what I want to take out of the second part. So I'm going to go ahead and write it right here, because if I want to factor this by grouping, I got to be able to take the same term out of both. Excuse me. And it turns out I can do this if I take out a negative 4, because negative 4 times x is negative 4x. Negative 4 times 5 is negative 20. That's, of course, equal to 0. My next step is to do some regrouping. So I'm going to group up these two parts as one. So x squared minus 4, and then x plus 5 as the other. Now, if I want to keep going and finding roots, which I do because I'm asking to find the zeros, this is found really quick. So this is going to be x equals negative 5. But then I have to take the square root and actually solve it. But if I have an x squared and minus 4 equals 0, because I want to know when they're 0, I can add 4 to both sides. And then I can square roots. So x is equal to plus or minus 2, which will be my next two roots. And again, keep in mind, since it's a third power, I expect 3 roots. All right, let's talk ACT preparation. So if the value of 4m, 4 to the m, over 4 to the n is less than 1, which of the following must be true? Now notice they both have a base of 4, which is a big clue here, which tells us that what we're really looking at is the powers. And so we want it to be less than 1. What that means is got to be a decimal, or it's got to be a fraction, because those are the only things that are going to be less than 1. Well, if I use some examples and start just kind of substituting values of m, if I have like 4 to the third over 4 squared, that's going to be the same thing as like 4, because 3 minus 2 is of course 1, 4 to the first power is just 4. But if I have something like 4 to the 5th over 4 to the 6th, think about what will happen here. 4 to the 5th will really just means 4 times 4 times 4 times 4 times 4, 4 or 5 times, and this is 6 fours. Okay, so we can start doing some canceling here, 4 for 4. But if you notice, I ran out of 4s on top first, which means that this value is actually the same as 1/4, or a fraction, or a decimal like 0.25, which gives us a template how to answer this. If I have a bigger power on top than on bottom, I end up with a whole number. If I have a smaller number on top than bottom as the power, I end up with a fraction. And so what must be true? Well, m and n both being 1 could happen, but that doesn't necessarily tell us if it's going to be a whole number. M being the same as n will actually not be less than 1. It will be precisely 1, because 4 to the same, like 4 to the 5th over 4 to the 5th is the same as 1, because we have same powers, which is what C was talking about. So these are no good choices. M is less than n. Well, that's actually this scenario right here. So that's got to be our answer. M being bigger on top will actually create a whole number. M being smaller will create a decimal value. All right, so if 3 and 2 are factors of A, which of the following must be a factor of A? So we have to understand what the term factor means here. If A has factors of 3 and 2, what that means is that A is literally equal to 3 times 2. Factors are numbers that multiply back to give you your number. And so if I look at 14 times A, that's the same thing as saying I have 14 times 3 times 2. In fact, I could take it one step farther and say this is really 7 times 2 times 3 times 2. Now the reason it's important to look at this number in this way is because if I want factors of 14a, it has to be a combination of the numbers I just circled. It has to be some combination of 7, 2, 3, and 2 in multiplication, which means possible factors are going to be these numbers is grouped together and multiplied. So like 2 and 3 make 6. That's a factor of 14a. 7 times 2 is 14. That could be another factor of a. 2 times 2 is 4. That could be another factor of a. 2 times 2 times 3, which is going to be 12, could be another factor, and so on and so on. There's more combinations, but you get the gist of it. And so we're looking in this list, it's for a number, one of these numbers that can be had by multiplying those numbers together in some combination. Well, 19 is not going to do it because that's a prime number. 11 is also a prime number. Remember, prime numbers are numbers that are multipliable only by them and 1. 8, although it's not prime, is not in our list, and there's no way to get 8 by looking at those numbers in multiplication combinations. 5 is a prime number, so that's no good. 4 is actually on our list right here, so 4 is going to be the answer to this one. And so we're looking at this ACT prep stuff. Like, it's really just about being clever with numbers. The better your number sense, the better you can answer these questions. All right, guys, that is key number 2. I appreciate you guys watching it. There's 2 more homeworks in these series that you get next week, and then we'll have our test quiz on October 26th. So thank you very much.